In this lesson, we'll be discussing number systems and learning to identify which number systems a given number fits into. The first type of numbers we will discuss are rational numbers. A number can be identified as a rational number if it is either a terminating decimal, meaning that it ends, or it's a repeating decimal. Here we have some examples of rational numbers, starting with 0.75. This is considered to be rational because it is a terminating decimal. This number ends at 5, so we say it terminates. 0.6666, this line above the 6 indicates the number continues with 6. So because this repeats 6 forever and ever and ever, this is considered to be a repeating decimal, and therefore it's considered to be rational. Same with 0.232323. This line indicates that this number repeats 23 forever and ever. So because it's a repeating decimal, we say that this number is rational. The other thing to know about rational numbers is that all rational numbers can be expressed as a fraction. So to show you that with our previous examples, you'll see that 0.75 can be turned into the fraction 3/4. 0.6 repeated can be turned into the fraction 2/3, and 0.2323 repeated. Let's see. It can be turned into the fraction 23/99. Irrational numbers are numbers that can be expressed as non-terminating and non-repeating decimals, essentially meaning that they do not end and they do not repeat. A well-known irrational number is pi. If you look at the digits of pi, you'll see it's 3.141592653, so on and so on. You'll notice with this number, it does not end, it goes on forever, and there's no repetition within your digits. So because it's non-terminating and non-repeating, we say that this number is irrational. Another irrational number would be the square root of 3, which is approximately 1.73205. And you'll notice with that decimal, it doesn't end, it goes on forever, and it doesn't repeat. So because it's non-terminating and non-repeating, it's considered to be irrational. One other thing about irrational numbers is that they cannot be written as a fraction. You'll see if I try to change pi into a fraction on my calculator, it stays as a decimal, which indicates it cannot be done. Same with the square root of 3 equals this one. If I try to change it into a fraction, it also doesn't work. So this would be the case with all irrational numbers. So finally, the set of real numbers is essentially if you took all of your rational numbers, all of your irrational numbers, put them together, that would form the real number set. So the next number set that we're going to talk about are natural numbers. So natural numbers are numbers that we use for counting. So these numbers would include 1, 2, 3, 4, 5, 6. This ... indicates that it keeps going forever and ever. So we'd have 7, 8, 9, and so on and so on. When we say we use these numbers for counting, it's like if we were counting apples, we would count 1 apple, 2 apples, 3 apples, 4 apples, and so on. We would be using the natural numbers. We use the symbol n to indicate natural numbers. Whole numbers are the natural numbers plus the number 0. So here you'll see we have 1, 2, 3, 4, 5, 6, and so on. Those would be the natural numbers, but the set of whole numbers also includes 0. One way to remember that is the word whole has an O in it, which kind of looks like a 0. We can indicate that something's a whole number with a W. So integers would include the whole numbers 0, 1, 2, 3, 4, 5, 6, so on and so on, but integers would also include the negatives. So -1, -2, -3, -4, and so on and so on. So we can indicate that something's an integer with the letter I,